in terms of DevOps and cloud, which will help you throughout your careers as long as for next 5 to 10 years at least. The reason being the slide deck is prepared in such a fashion that it gives you the basic prior to cloud or prior to DevOps, and also what DevOps is all about. It's going to be more practical use cases, lots of demos, and more on the case study. How is it consumed today, rather than just being an academic session? If you have more questions, you can always put your questions in the text box there, and I will take 15 minutes at the end of the session. I'll be only taking questions and answer them. Right. So let's get started. So my name is Anil. I am a senior consultant working on cloud and DevOps. I've done several implementations of cloud on OpenStack, India and abroad. DevOps, I do consulting on CI/CD pipeline and automation stuff. So we're gonna first jump into DevOps. That's the first area of topic, and we'll do lots of demos around DevOps just to understand theory and concepts. So basic agenda is we look at agile framework before we jump into DevOps. Okay, and post that we'll see what and why of DevOps. So before you understand DevOps, you need to look at the evolution of why actually DevOps came into play. So agile is something I need to discuss. I'll talk about some case study on DevOps, how it is being used practically today's industry. And of course, we're going to end up with a live demo. Everything we discuss, we're going to show a demo use case for the same. So let's get started. Now coming to Agile framework, again, prior to Agile as a software development, we had something called as waterfall model. So it all started with waterfall model. During your engineering colleges or anything, if you are software associated, you would have learned this term, waterfall software development lifecycle. So basically this model is actually the prior to the Agile. In this, we had phase one where we had a requirement gathering or so-called analysis phase. So let's say I want to have a travel portal developed by a client, right? So ABC Limited in New York, they say I want to be a travel portal company and asks Infosys that I want you to develop a application for me. Now Infosys sales guy is going to meet the client at ABC in New York and understand the requirement of the client, analyze it first. Next step, there's a designing phase where you have a software architect in Infosys who will start designing the front end, the UI UX, the back end part, which is a database. What kind of database should I have? Should I go with Java application or a PHP? UI UX should be on maybe Ruby on Rails, for example. Should I do a microservice? So a lot of design phase goes into it. And then probably the coding starts, where once the design is finished, we need like 10 modules. Module 1 for flight booking, module 2 for train booking, and module 3 for bus booking. So, and module 4 probably for a holiday package. So similarly, they start coding the stuff, and of course, we need to test our code before we deploy it at the client place. So once the coding is done, a proper test use cases are written, and once the tests are through, we finally package it. So packaging, if you are not a developer, is like creating a .msi file or a .exe file in a simple words from a layman perspective. So packaging is like packaging the entire product in such a fashion which is deployable, right? So if you download MSI, you install it, it's an installer, right? Same thing. And once you package it, you deliver it to your client, and client will start using it. So this waterfall model has some challenge. One of them is basically the customer requirements change, right? So when you meet your client 10 months back and he gave you your requirement, and you took 10 months to develop 10 features for him and go back and say, hey customer, I'm done. But customer requirements would have changed over a period of time. So that's one other thing waterfall model has a challenge. which means it doesn't involve any feedback from the client. So that's exactly right. So lack of involvement with the customers. So customer says, "I'll meet you when the product is ready." That's a kind of deal people make today, right? In waterfall. So customer is not involved at all in any phase. Okay. So customer says, just to add some humor in webinars because it's kind of died out otherwise, right? So customer says to developers, "You know what I meant during our initial discussion? He says I wanted sweets, but you have given many sweets." This is what happens with most of the developers if you don't involve customers, and then they feel personally they get engaged so much in the project that they keep adding more interfaces, which really customer is not asking or really need it for, right? So that was problem with waterfall. As a result, your schedule overrun because you said 10 months I'll finish your project. You go back after 10 months and he says, okay, this is the change I need. That's where you need few more months to complete your project. So let's say 2 more months to close all the loops. Then your cost will overrun because you budgeted your resource for 10 months and now you have to pay 2 months of additional effort, and customer is not going to come and pay you back for that. So that's what happens with last minute changes and new add-on feature requests which comes in from your client. Now, Agile framework, basically in this case, Agile came as a solution to the problems you saw in the waterfall. So what these guys did, they said instead of sequential design, let's go at incremental approach. So what does it mean? So just imagine there are 10 features required from the client. What we do is on month one, we develop feature one and show it to our client. So we start with like very basic simplistic design. And this came out of real project experience, like people like you who are project managers who develop a lot of software to your client, and you saw what are the problems facing. So you said, let's start with the simplistic design. Example, you just start with the UI UX in month one, where you have entire UI UX developed, all the blue fancy website done. There's a tab for flight booking, there's a tab for multiple other services, and you present your client saying, hey, this customer, this is how it looks like at the end of your product life cycle. Now, he clicks on flight booking tab, nothing works because there's no code written. It's just the UI UX and the design part on how interfaces will be looking like. So that's the best approach, right? So once client says, okay, this looks good, you start doing the coding behind the scenes. We call it smaller modules. Now, we do not write something like single module which does everything. Like, when you talk about example like makemytrip.com or any flipkart.com, right? So there are multiple modules for doing multiple other works, not like single software application. So basically these modules are done in a weekly or monthly sprints, depends on the company. And there are tests which are run. So what happens in the month one is you have the UI UX approved from the client. Month two, you click on flight booking. There's a lot of code written which takes care of making API calls to different flight providers, capture the flight availability and the price onto the portal. So second month, you provide the same URL to client, and this time when he clicks on flight booking, that stuff works. So that's the advantage of this particular framework here. So you continue to do it for 10 months. So month three, you provide again another URL where they click on bus booking, it also works. But month one, customer says, okay, UI UX looks good. I don't want this completely blue. I want it in a gray format, right? I want tabs to be more on a modular way. So any feedback comes, you fix it there. Second month, you did a flight booking. Customer says, I don't want details on horizontal way. I want vertical way. So things like that. You can fix it in the same sprint. That was the advantage of Agile. So basically, you have early bug detection. So what happens is month one, you delivered a project, you have some issues, you fix there, right? So month two, you have another issue you can fix instead of waiting for all the way 10 months and then fixing issues. Okay, so quickly I want to know, because it's webinar, I have a habit to do a small quick check. Can somebody write difference between waterfall and agile before I step into next steps on your chat box, please. Oh, sorry, I saw your message now, 7:30. I think we are all in mid of the session. Sorry, I saw your message now. Guys, can you please participate? So what's the difference between waterfall and agile? Very quick. And I'm not sure as a user able to comment. Okay. All right. So basically there is a small difference between waterfall and agile. So waterfall is always in mainly like you start with day one, you end with day 10, where you don't involve any customer feedback. But in case of agile model, you take customer feedback on a sprint basis, which could be every month. So there are three slides which is going to make you absolute clarity on difference between these three technologies. So let's see the IT evolution. So early 2003, if you look at, we had so we have like waterfall model in the development process. We have application architecture was monolithic, which means a single application used to do everything. Of course, we did not have Flipkart then, but example, you had like makeMyTrip.com or a Flipkart those days. It was like single application used to do website delivery. It used to manage the cart IDs, whatever products you put in the cart. It used to do order management. It used to also manage the username and password authentication. Like single app doing all the work. And basically that Flipkart.com example, maybe let's say if they were available, it was deployed on a physical servers on top of OS. And of course, customers did maintain their own data centers physically. So this was the year 2003 in the early IT evolution. And if you look at the left-hand side at this moment, on the development process from waterfall, we move to agile, and you know the process which I discussed. But what the other areas you need to also focus is application which are monolithic. That's the second option, which you see there. It's now n tier, means basically you have a web server, application server, and a database server, right? So we have client server architecture coming into play. And third aspect, which is deploying your application. Earlier we deployed on physical servers. Early 2008, we have a technical or a non-technical person, right? So we all know VMware as a company because they came with virtualization. And if you wanted 100 servers to deploy 100 application, they say, okay, buy 10 servers and I'll do the same job, right? So advantage was there. So people started deploying application on virtual machine. On the application infrastructure, which means earlier, which we used to maintain our own physical data centers, like server, storage, network, rack, and everything. But when it comes to 2008, we got some hosted models, like we have Reliance Data Centers, TCS, right? So NetMagic and many other companies where we said, it's here is my hardware. I do not have the data center capability, and I start hosting my server, storage, and network hardware at the data center provider. But hosted was like typically you commit like, okay, I'll use this server for 3 years, right? You can't exit from the particular contract unless you finish your projects. So now, just a quick check. What do you think you get after waterfall and agile? What next do you think you should get? Okay, let me pause for 30 seconds just in case somebody is participating. Okay, so basically after waterfall and agile, we have DevOps. So that's what is the next step in the world. See the third part here, that's the DevOps, and now we're going to get into more exciting phase where we'll talk about port tools because this is important what we covered now. Unless I get you from waterfall to agile to DevOps, you really can't nail what DevOps is, right? So now coming middle more closer to DevOps definition. So DevOps is dev and ops. If you see there is a dev part and the ops part. So we'll discuss about exactly difference between both. But as a nutshell, DevOps is a federation of development and operations team. And application architect like single application in 2003. We had multi-application in 2008. Today's world where we stand, we have microservices, which is like today when you go to any e-commerce site, right? So let's say a travel portal. So there'll be one website which is travel.com is written in, let's say, Java. And when you click on flight on that particular thing, you get flight.travel.com because there's a module which takes care of only flight booking. When you click on train, there's a module which takes care of only train booking. But all of them are interacting with each other, and they're not saying, okay, go to like flight.travel.com to book your flight. They say, okay, come to travel.com. I'm a single shop. I'll give you everything. So microservice is single service which can be offered through different modules. No? So flight module is one service. We have travel module, for example, is another service for train, one service for bus booking. Now the advantage is, let's say you go to make my trip and you're trying to book a flight and there's an error in flight booking. That doesn't mean you can't book a bus or a train, right? So the microservices are independent. That's how things are working today. But make my trip is just an example to correlate for audience because it's popular website for travel. But we are not aware internally how make my trip works. But just to give an answer. And today's world, we are going to run everything on containers. I'm going to discuss more on containers a little bit more time from now. But essentially, this slide gives you an idea about what's exactly happening today. So today, I deploy application on a container, and Docker is one of the very popular tool there. And the fourth area, we are actually going from hosted to the cloud model. So that's where we stand. So from hosted, which means earlier 3 years contract, your project completes, you still pay for 3 years. Now people are deploying applications on cloud where you spin a VM for 10 minutes, you only pay for 10 minutes. You don't want that service next minute, you can just cancel it. You won't be charged from the 11th minute. So that's the advantage where people stand. If you are right now in your careers anywhere in 2008, so this is what I want you to be in. Like if you're a developer, you should be in DevOps. You're just an application developer, then you should be in microservice. You are in virtualization, you should be moving to containers. You are on hosted, you should be moving to cloud. That's the journey today. So I'm going to pause for a moment here and we'll get good to the next topics. Thanks for holding on. So next step is looking at what and why of DevOps. So basically, there's no single definition on DevOps which you see today in the industry. At least somebody is not concluded, okay, this is what DevOps look like. There are many definitions. I'm just trying to give you more closer definitions which are available. So DevOps is one part. It's not a technology or a product. Like you cannot go to a company like IBM or a traditional HP or a EMC saying, okay, I'm looking at DevOps, so sell me a product. They can't. So basically, DevOps is a collaborative ecosystem of people. The people is the consumers of your product. Those are the people who are involved. That is like if you are accessing any government website, you are like a people, right? So you're like consumer of it. And there's processes, how things should work. There's a product development team. That's the developer guys. And there's the operation guys who actually provision machines for you, right? Who provision application software and everything. So DevOps, as I already discussing, it is development and operations. And if you look at the goals of DevOps is trying to bring in a better communication and collaboration between these two units. So that's the development team and the IT operation team. So this is the most widely, I'll not say adopted, but most widely accepted definition of DevOps today. So people say anything which is like collaborating my dev team and the ops team, these business units. So I'm actually doing DevOps. So that's what mostly people believe in. And the DevOps means many things for many people, and it can be articulated in a different way, right? So two slides which will give you more clarity again between what Agile offered and what DevOps is offering. So these are the two best slides for the day where you really can nail what is the difference. If you look at in Agile, we had two involvements. So we had business team, right? And so there's a business team and then there's a developer team. And what we got with Agile is business agility. What does it mean? Like we are very close to customer requirement because every week we had a sprint. We took the feedback from the client. We went back. We again recoded everything. We changed, modified, tested it on the same sprint, and we like iterative development, right? So it's a business agility means as per the business requirement, I'm able to develop an application. So that's what actually Agile gave us. But Agile did not give us IT agility. If you look at IT operations is left out here on the left hand side. So today when you say DevOps, it offers business agility as well as IT agility. So what we are doing now, we are involving the IT operations inside the framework. See, we are not trying to hate Agile because Agile is really great. But Agile, what happens? Like every sprint, for example, let's say every week we have 10 changes. So I had to go to operation team and say, hey, you know what, I need your help in spinning up a VM and I need your help to install Java on it, install a Maven, and then install Tomcat, and then give it to me, right? So it's like developer has to request the operations team every time they do a code commit and ask for a machine for to be provisioned, right? They need more machine for test productions or even pre-production kind of environment. So that's what we saw. But the moment we integrated everything, where we said the moment developer changes the code, the IT provisioning happens automatically, right? So that is where the key thing is. So we got IT agility means every day, let's say 100 different changes in the code, 100 different VMs will spin and they will do all the job you want. There's like a continuous integration tool which takes care of it. So DevOps lifecycle, basically it has development, test and release, deploy, monitor, operate, and plan. So take an example. So planning, right? So here is where you have customer requirement. The sales guy at Infosys, he flies all the way to New York, and ABC Software Limited says, okay, I want to be a travel.com, right? So that's the first phase. Then developers will start writing the code. Then there'll be test and dev engineers who will actually do the test and release the software. When you say release, it's like, version 1.2 or version 2.3 examples, right? They're not like just an application package installed in your laptop. If you look at the current three phases are the dev part of DevOps. In dev part, you have planning, development, and test and release. But now your end product is ready and you sell it to your client. So client, let's say he has to deploy 100 servers. So that is where deployment comes into play. And deployment is taken care by the infrastructure team. There's the IT infrastructure team whose job probably there's a VMware administrator. You'll create 300 or 100 VMs based on the need. So that's where the ops part comes into play. And they'll deploy the servers and then deploy application. And there'll be a team for monitoring and operations, right? So there's an ops team who's monitoring the health of your VM. Or what if your VM went down, try to recover it. What if OS has issues, try to troubleshoot it. What if the VM went beyond 70% CPU, how to add more VMs, all of that, right? So basic operation, guys. So if you look at clearly, deployment and monitoring and operating. So these are part of the ops part of DevOps. So this where predominantly in ops part will be your Linux admin, the storage administrator, the network administrators, and so forth. So what happens now is take an example that you visited a site, you tried to book a flight and you could not, right? So you say report the error, right? So when people report the error, again the planning team gets involved and they will tell the developers, okay, hey, in the flight module booking, we see there's a problem and somebody booked a flight and this is the issue. So developers will download the source code, troubleshoot it, bug fix it, then again goes through a testing of the new version patch and then release. It's given to the deployment team. Deployment will deploy this time no VMs. They will deploy the application version. And again, your monitoring team will start monitoring it and start reporting, okay, everything looks good. So if you look at DevOps lifecycle is not an ending process, it's a journey which you keep continuing. It's not like end of the show. So now under the hood in DevOps, what exactly you get is the technical stuff, which you guys will be interested because it's not been everything about process. And now we get into the technology piece, which will keep you more motivated to listen, right? But believe me, all that DevOps culture is very important because DevOps is not just tool. So what tools are helping under the hood becoming DevOps is so popular. If you look at virtualization came into play in 2008, but adoption started only early 2012, right? So people, full adoption I'm talking about. So people were like, okay, let's wait and watch and all that. Then cloud came in early 2008. It took almost 6 to 10 years for people to adopt it with open hands, right? So basically cloud took some time, 10 years or so. But DevOps is the only area which just came in, got an introduction in industry and started getting adopted. That's because it has 100,000 reasons why you should adopt DevOps. But thanks to the technical tools which are helping them on the back end today. So let's see what they are. So I'll quickly cover before DevOps and after DevOps, and we'll see how things have changed. Before DevOps, we used to write code and we still do, right? So we used to do a compile and package, then deploy a web server, deploy the application on that web server, do a testing like single server, do a test, UI looks good, people can log in, book a flight and everything. So when that test is complete, then you do a release. You say, okay, IBM, we announced a product version 2.0 for travel.com, right? So that's a release. Now that software release is taken care by the client and he manages the configuration management. Example, so once Infosys develop the application, gives to travel.com. So travel.com job is the last part, which is configuration management. His job is to configure, let's say, 100 servers which are running Linux. His job is to install Tomcat on all the 100 servers. It's a job to deploy the application on those 100 servers, right? So basically the config management part. Now before DevOps, we have done everything manually, and it also means that you can still do it manual, not a problem. But imagine companies, I don't name them. So there are companies which are home known names. They do a software release and deployment in 13 minutes, every 13 minutes. Imagine every 13 minutes you have to release a new software and you are doing manually. Can you do it in 13 minutes? That's where it's a big problem. And let's see what happens after DevOps. After DevOps, we still have the same phase, nothing different, right? So there's a writing code, we have to compile and package the code. You have to deploy it on machine, you have to do some tests. If all good, release it and then deploy it in the client location. Now in this, writing code is still manual, as in you can't automate writing a code. So again, there are debates. There are software tools which help you to just drag and drop. Maybe you want a calendar on your website, you can drag and drop a plugin. It has all the code it takes, right? But still somebody has written the code which does the job, right? So we still say writing code is going to be manual. So that's the jobs 100% going to be available. You don't have any issue with that jobs. Now compile and package, deploy, test, release, config. All of this can be orchestrated and automated. So I'm actually doing a consulting as we speak on no ops, which means Without any operations team, the client is going to run entire show of deployment of application and management application. So that's what no ops is all about, because we can just automate everything, and we don't need manual intervention to do any work. So apart from writing code, compile and package, I can tell Jenkins, okay, go talk to Maven and get the compilation done, right? I can tell Jenkins, go deploy a VM and tell your Maven to run some test cases and result it back to me. You can tell Jenkins, okay, manage the release for me, or talk to Jira and tell him, okay, this is a new release of software. So there is orchestration tool like Jenkins, which can help you. We're going to discuss more on it, but just in a nutshell, wanted to cover a little bit of what is happening after DevOps. So the tool set, we have broad classification. One of them is called as version control. Followed by that, we have tools under continuous inspection. Now, when you say version control, means you bring up all the software source code in one place, right? Then continuous inspection. So these tools will keep inspecting your code as it change. There are tools for building your packages like a .msi, .exe or a .zip file. And there are tools to do a testing for your software. There are tools which we call as CI/CD, which is continuous integration and continuous deployment tool. I'm going to do a live demo on CI/CD, which will give you absolute clarity. But for now, just remember that there is something called as continuous integration tool, which keeps talking to your source code, and it says, okay, source code says I have changes in my code. His job is to do everything he wants. So then we have the configuration management tool. Basically, these tools automate deploying your VMs, deploying application on that VM. So both the tasks. Then finally, you have continuous monitoring tools, which are like monitoring your application health check and also monitoring the health check of your machine, whether the VM went shutdown state, or let's say a virtual machine CPU reached 70% or 80%. So that's what those guys mean all about. Now, in version control, the popular tool is GitHub and Bitbucket. So let me quickly give you a heads up on this. So github.com is actually a public cloud portal where you can create your account. Just pick up a username or whatsoever you like. Provide and then you can sign up for GitHub. So I do have an account, so I won't create it, but just want to show GitHub is a place where you can store all your source code. So I'm just going to sign in here. So first thing you do in DevOps is you bring all your code and store it in one place. So that's the job actually. So you see, this is my dashboard. So I have several repositories on the left hand side here. So I have a repository called as Cloud Enabled Web App. Basically here I have a Java source code. If you notice, it's actually a app test.java, just basic Java code, nothing compiled or packaged. So what we use for GitHub is to store all our source code in one place, right? And then it also has HTML files which it has to stream. It deploy the index.html logo of my company, or style.css and all of that. So this is one place where you can store. It's completely free of cost. You can create a repository, and in that repository you have two options, public and private. So I can just call it as let's say demo cloud, and then if I do public, I don't be charged for it. But if I choose private, so this repository will be charged $7 per month. So what does it mean is, whatever I store in private repository, people cannot download. Okay, if I store it on public, people can download. So there are two options in current source code management tools, public and private. So public, of course, you may not want to, because you're writing so much of code, investing your developers, and people can just download and start using it. All right. And from a private perspective, you can store the code, people will not be able to see it. The public can't see. It's only you who can log in and use the code. That's a typical difference here. Second tool we also have is Bitbucket. So that is also exactly same. So we can just go ahead and sign up, and you'll be able to create some repository and store your files there. And coming to continuous inspection tool, so one other tool is called as SonarQube. So SonarQube is basically a static code analysis tool. What it does, it will tell you how many lines of code you have in your software. Let's say on GitHub, the code I shown you, it has, let's say, 100 lines of code. It will tell you, okay, this repository has 100 lines of code, and in this particular repository, how many bugs are there, how many vulnerabilities are there, and it will also tell you that, okay, the code is written like this, it could have been written like this as well. It does some recommendations for you. So that's the best part of SonarQube. It's open source, and there's also commercial version from HP called as 45. So let's quickly show you something on the SonarQube as well. So this is the sonarcube.org. It is completely open source. You guys can also download and install it. And if you notice, it's supporting 20 plus language. Like if your code is in Java, you can give him. He will tell you, okay, as per Java best practice, you have some deeper problems. So code smell is like a deeper problem in your code. Bugs, of course, you are aware. You need to fix, otherwise you can't move on. Vulnerabilities, probably there are some security loopholes in your company, product. So around 85,000 plus companies are using this already, and the current release is 7.3 as of the latest. This is a dashboard it looks like, right? So let me little maximize it. These are your reports will look for your product. So it'll tell you, okay, this code has 4 bugs, 11 vulnerabilities, there are loopholes, and code smells means a deeper problem in your code. Code coverage 90% of your code, and 18 test cases have been run. So it's a complete code analysis tool. Really helps you out to figure out what went wrong and where you have a problem. And this is how it shows you tricky issues, right? So it shows you, okay, line number 140 and line number 147, what issue you have here. And you can assign this to your developer. So it's easy, right? So you just say, okay, assign this bug to developer number 5. So you can do that. If you fixes it, you can come back and update, okay, fixed. That's a easy job here. So SonarQube runs on Linux, and it supports the programs like ABAP, Flex, JavaScript, PHP, XML, Go, Object-C, PLSQL, Swift, and many more. And this completely open source. You can use it as it is. So that's the static code analysis tool example. There are many others. You can also research around on internet, but I'm just showing you what is getting deployed in real time. So now we covered version control, we covered continuous inspection. So now we are moving on to a build and test tools. So in the build tools, they are no different. So we still have the Maven. So Maven is very popular for Java. It just allows you to compile your code in a human readable fashion, and then probably package it and then deploy it, right? Now other than tools, you have Selenium, Cucumber. The tools are same. It's just that it's very early to discuss right now, but you can tell a tool called as Jenkins, okay, go talk to this guy Maven and ask him to compile the package for me, right? So you can do that. You can orchestrate it. So what people are doing today is using the same tools on the backend, but put some orchestration like Jenkins who takes care of it. So in a minute, I'm going to discuss about Jenkins. So that's part of the CI/CD tool. So CI/CD tool is like continuous integration and continuous deployment. I have a slide, so I'm not discuss right now. I will leave it for little later part of the time. And configuration tools. So config tools here again, I'm going to discuss about all the three, but the popular ones are Chef, Puppet, and Sibyl. So what you can do is Jenkins does all the job and say, okay, here I have a code for travel.com, right? So you can give it to Chef or a Puppet or Ansible and ask Puppet to deploy it. You can automate that. And for continuous monitoring, we have tools like Neuralink and App Dynamics. These guys monitor your application health check. You can tell, okay, let me know my application health. How is it performing? How many hits are coming in? When it went down and all of that, so forth. So broadly, these are the classification of what is widely used today in the industry. Now putting everything together, let's say a user, which is a Java developer, he has Eclipse on his laptop. So today, let's say travel.com was developed on 9th month, client says, okay, Anil, I want you to change the logo, which is on the right hand side, should be changed to the left hand side. Now out of 100 developers, there's one developer who worked on this feature of logo, right? So what the developer number 55 can do is go to his own desktop and just changes in his code from left hand side to change to right hand side, and then he will click on save. The moment he clicks on save, which is a commit, today there is plugin called as GitHub plugin. What it can do, it can inform GitHub that, okay, I see there is a change in the code. Now remember, there are 100 developers who have stored all the code in the GitHub. It includes the developer number 55 who contributed for the logo as well. Now there's only one change from developer 55 and not changes from others, right? But what happens is, if you make any change in your source code, it has to go through a process of packaging and deploying, right? So you can't just copy a file somewhere. So then the best part, GitHub can inform a CI tool called as Jenkins. So what Jenkins can do, it does something called as continuous integration. So it will talk to GitHub and say, okay, can you help me if there's any change in the code? Is constantly asking GitHub every minute. So at 11 o'clock, GitHub says, okay, I don't have a change. At 11:10, he says, I don't have. But 11:15, GitHub says, okay, hey, I have a change here. So that's where Jenkins starts. Then Jenkins is where we write some code as a developer saying, okay, whenever there's a change in the code, what are the set of tasks Jenkins has to perform? So we need to write a job. So first step, we'll say, okay, if there's a change in the code, do one thing, just launch a VM first, right? So VM is nothing but a slave node. Jenkins works on a master slave concept. So Jenkins master says, okay, there's a change. Let me launch one VM first, right? So it will launch one Linux VM on Amazon, and then it will download the latest code onto the slave node. It will send the data to the SonarQube for quality gate analysis, whether the code is good, bad, ugly, whatever. And once SonarQube says, okay, the code looks good, Jenkins will tell Maven, which is installed on slave node, okay, please package it for me. .war file gets created, and then the war file is actually the end product. It's like a .exe or a MSI in Windows world, right? .war is like same in the Java world. So we have another tool called as Nexus. Basically, Nexus is like a cloud storage where you can store your .msi, .exe, .jar, .war file, anything which is your end product of your project. So that's, let's say, name it as app.war. Now we have automated the dev part of DevOps. If you look at, this is all involved in the dev, not the ops part. Now app.war is developed, right? So I have to deploy it on the machines. So that's where we can also tell Jenkins to talk to something called as Ansible server. Now Ansible is a configuration management tool where Jenkins will tell Ansible, okay, here is my war file. Can you create a test environment for me? Ansible will create it and also deploy the application for me. Let's say, so Ansible will deploy 3 VMs, configures everything what Jenkins has asked for, and app.war gets deployed. Now, if this looks good, you can write one more piece of code. Okay, now this looks good. Let's go ahead and deploy it on the 1000 servers. Now, if you look at what triggered here, this is called a CI/CD pipeline, continuous integration and continuous deployment, right? So 11:10, somebody committed change in his developer machine. GitHub got informed. GitHub told Jenkins, okay, there's a change. Jenkins went ahead and launched a VM, downloaded the new source code, compiled it, packaged it, copied it onto the Nexus, told Ansible, can you deploy it for me? And then Ansible started deploying the application for us. And test environment looked good. We deployed it on production. Now this can be fully automated without human intervention. We can write test cases. We can tell Ansible once you deploy app, keep listening on port 80 and for keep pinging him every 30 seconds for at least 5 minutes. And what if the pings are success, then deploy it on the production environment. So I can tell that as well. So this is continuous deployment happening. Anything which is Ansible and below is called as ops part of DevOps. Anything which is Jenkins, which is above Ansible, it's like GitHub, slave node, and the Nexus. This is the dev part of DevOps. I hope you are clear now. Okay. Between, if you have any questions, please post them. I'll be happy to take. Next step. Just to summarize, DevOps is two parts. Dev part, and in dev part, what we have a source code management where all the source code is stored. That's your GitHub or Bitbucket. We have code analysis tool where you store all the code and do an analysis like your SonarQube. Then we compile and package in the dev part of DevOps. We automate that. We have a continuous integration and continuous deployment tool. And basically we have a release management. So like example, Make My Trip or a travel.com, version 1 has 10 holiday packages they are selling. Version 2, they might come with an offer saying Europe at $10,000, 10-day holiday package. They just want to brand themselves, right? So if they want to launch a 11th holiday package, remember they can't just push the file of Europe.html to all the machine. That doesn't work. It has to go through the proper channel, which means somebody has to write the code, which is holiday Europe.html, submit the code on GitHub. Then SonarQube has to analyze it. Jenkins has to say, okay, code looks good. Let's go and compile and package it, and then deploy it and manage the release management software like version 2 name, right? So that's the dev part. The ops part. So once Infosys releases the software to the client, so travel.com, the company, right? So he will have his ops team, and the ops team at the travel.com job is to deploy it on either virtual machine or the containers, right? So he has to deploy, let's say 10,000 VMs, which is manually today. And once VMs are deployed, he has to update all the 10,000 VMs with the apt update command. Then he has to install a web server, which is Tomcat 7, right? It has to deploy the application, which is java.webapp.var. Manage the configuration, like it should update details like which database it should talk to and all of that. And then finally monitoring whether application is up or not, or whether CPU memory is all good or not. So basically there's a clear differentiation between dev and ops in the industry, but because vendors want to sell their product, somebody claim we are a DevOps company. Not everything is being done by everyone. Everyone touches some part of DevOps, not everything. But there are tools which do end-to-end. That's also there, but you can't just go with one tool in the industry. So dev part, just to summarize, you have GitHub, Jenkins, SonarQube, and then Jira release management, right? And when you talk about ops part, you have Chef, Puppet, and Ansible. So using these tools, you can automate and orchestrate all the things which you have done manually in your life. That's all is DevOps all about. If you really ask me what is DevOps in a very, very low level definition, is it is you're providing IT agility to the business agility. That's actually DevOps in a very, very easy language. So just automate everything you can claim you're doing DevOps. That's what DevOps is all about for some. If you can orchestrate everything, then you are doing DevOps. So quickly on continuous integration, so we have developer 1, let's say, I hope everyone knows Dropbox.com here. There's upload.java, developer one writing it. There's a code when you right mouse click and click upload, the file gets uploaded. Then we have developer 2 who is writing the code which is download.java. Like when you right mouse click and click on download, the file gets downloaded, right? And then we have delete.java, so developer 3. So what you actually do is consolidate all of it and just put it onto the github.com. Okay, you getting it? So it's basically developer 1, developer 2, developer 3 is going to upload all the files, keep it on one place, and then we have Jenkins. Is a CI tool. The moment there's a change, it should be notified, right? So let's say client says, Anil, delete folder which looks actually blue in color, can you change it to red? So now what happens? Developer 3 will commit the change on his laptop, and GitHub will go ahead and inform Jenkins, okay, there's a change, and Jenkins will trigger a job which is a slave node VM, and it will compile package and deploy it. So actually Jenkins is not the only guy. There are many other tools in continuous integration like Jenkins, Bamboo, CoreShip, Travis, TeamCity, and many others. So basically, CI is a development practice that requires developers to integrate their code in a shared repository several times a day. Each check-in means every time we make a change, it should be verified by automated build, allowing teams to detect problems early. Let's do a quick demo on Jenkins, Sonar, and the slave node. So I'm using AWS Cloud. If you look at on AWS Cloud, which is north of Virginia, I've deployed a VM which is running SonarQube and Jenkins. So I'm just going to grab the IP address for this. So colon 1890. So this is actually the dashboard for Jenkins, which will come up in a minute. Okay, so that's admin account and password, and I should be in. Okay, so basically this is the dashboard for Jenkins, and last week I was in Singapore, so I used the same demo which I did for Singtel here in Singapore. So it's going to use the same thing, that the code will not differ, right? Basically it's the same job, so we're going to repeat again. But basically all your jobs show up here, and what jobs are nothing but you put all the piece of code what it takes to deploy your application. I can create a new item if you wish to, and I'll show you some part of the code just to show you guys. Let's call it as a demo app, and we call it as pipeline, and click OK. And what you do in the pipeline is you start writing code. This is the only piece of code you have to write where you say what the first step, right? So you can just go ahead and use pipeline syntax if you wish to. So there are steps. So first step, what you do is you need to tell him on which node to run, right? So there's slave node and master node. Okay. So tell him, okay, I want you to run on slave node. Right? So node slave one, and then you write what is the job to be done. This is where you write all the piece of code. You're saying Jenkins, whenever there's a change in source code, do this task, but this task should be done on slave one. Example, you have slave one, which is VM1 running Ubuntu, slave two, which is CentOS, right? Can define on which node to run. But if you want to run it on the same server, which is as master, you can just do it on, just say node and don't give any name. So when you say node space curly bracket, that means run it on the master node. which will be the same machine as 34.203.188.189.9. So what is the first task you want to do, right? Whenever there's a change in the code, the first task is you want to download the source code. So for that, we have a git step. You have to tell him where the software source code is pending, right? So we go back to our GitHub. So this is the GitHub account which I have. And you can notice I have some repository called as cloud enabled web app. So this is completely non-compiled code, pure source code written in Java. So we just click on this, that is get me the URL, and go back to the pipeline syntax and just go ahead and generate the pipeline script. And this is your second task. So we are saying the moment there's a change in the source code, what you do a git clone. Apart from this, of course, once the git clone is done, you have to install Maven, right? So for packaging. So for that, they have a shell option, because end of day, you need to execute a command. So you can do a sudo apt install Maven. The syntax is simple, right? So it's like sudo apt install Maven, right? So in this task, we are saying anywhere there's a change, please download this guy and then install this guy. But after Maven install, you want to do a compile, right? So you can just do sh single quote sudo mvn and compile. Once compile is done, you want to do a package, so sh sudo mvn package. So basically, this is a series of tasks you mention on which node to run and what are the series of tasks you want to do, right? And then you just save it, and you have option called as build now. Once you click on build now, what will happen is it will start working on the tasks. You see build number 1 got triggered. If I go to console output, you notice it says running on master, because I said node without definition of which node. So that's why it runs on master node. So first thing first, it creates one directory called as workspace demo app. And in that, it is going to clone the entire source code. And after that, if you notice, it is doing the Maven installation here. And if you notice, it says already installed, because my machine is running Maven as of last demo. And then it is running Maven compile. You see, this is all the compile output for a Java. Then it is doing Java Maven package, which is also a packaging output here, right? And finally finished with success. So basically, this is the CI/CD, basically CI right now, not the CD. So now that you know what this code, how I generated, I'm just going to run to another one, which is web app synctel. So this has all the code, what it takes to deploy. This is called as pipeline actually. You know what stages I have developed is clone from GitHub, which is first step, install OpenJDK, then install Maven, perform the Maven package, archive the artifacts, means I want the Java code, install Tomcat 7, and then finally deploy the application on this guy. So quickly what I am going to do is connect to this machine. So that is CentOS server on which I am running this. I think it's not yet connected. Okay, some issue logging to this guy. Oh, sorry, it's a Ubuntu OS. It depends on the client. We keep switching the operating system. So that's Ubuntu operating system. Okay, great. So we are actually at Ubuntu at this IP. That's nothing but our server. Switch user to root. If you are new to Amazon, actually this IP is same as netted to public. If you look at this VM has two IP addresses. One is a private, which I use to SSH, and it has a public and then a private IP, which is ending with 233. I'm connected to this IP address. So I'm just going to quickly do a apt remove maven, apt remove. Uh, Another thing is git. I want you to show with some error. I also want to delete Tomcat 7. Okay. So if I do a service Tomcat 7 status, you can see it's not running, right? Because already removed. And if I do a git, it's giving me error. Let's go back and just look at our pipeline first, what we have. So if you don't understand the entire code, it's absolutely fine. Don't stress out. Just because it's important that it's magical, it works, but why it worked, you need to know. So basically, I told run it on master node, which is the same IP as this. I told him to first download the source code, right? So that's the first step, GitHub. Then install JDK, install Maven. Then I've told him to do a Maven packaging. I've asked him to archive the artifact, which is the WAR file. I'm asked him to install Tomcat 7 and then also deploy, which is basically in Tomcat, right? If you want to deploy application, it's basically copy the WAR file to the varlib Tomcat 7 web apps. Okay. So I'm just going to copy this path as well. And so if I do a CD, because of the last webinar I did, so we already have it. So I'm going to do a rm-rf star here. So there's no web application running, right? So nothing is copied. So everything is same as early. So now I am going to go to click on build now. And you'll notice the build will fail. Okay, so if you see the build has failed, that's a red mark here, and we failed for GitHub cloning. The reason is it says .git repository, but it doesn't. It appears to be correct because Git itself is not there. That's why this pipeline is failing. What I need to do is at the very beginning of my code, I need to add. You can do it manually, guys. So I can just go and install a Git here, but not that is the process. So I can add a stage before you even do a Git clone. First install the Git client, right? So install Git client, and you know the code by now. It is sh because it's a single command, and single code. Just say sudo apt install git -y. Right? So this will install the Git. You need to use -y, otherwise it keeps asking for response. Now if you do a build, so this build should be a success. You can notice all the other things have went away. So there's a Git client. So this was success. So Git client got installed. Now Git clone is happening. This won't error out because you see cloning the repository. Because Git client is required to clone repository. It could, hopefully they should be able to do. There is an error which we can fix, of course, not a problem. Yeah, so unable to delete this workspace, right? So basically we already have a workspace. It's trying to create a new one. So what we can do is we can just go ahead and Back to dashboard. We create a new job. We call it as demo Anil pipeline, and then copy from web app. Simple. Since we have all the code, we don't have to write again. That's the easy job. So exactly same code, right? So we run a new workspace. That's it. And you can notice the demo Anil is complete. You know why? We did an install Git client. So Git client is a success. Installation done. Git clone took like 635 milliseconds. Look at the log, cloning the Git repository. So what basically happens is it does series of tasks you asked, right? So then it installed JDK. It's required to run my app. Then it installed Maven. Maven wasn't installed, right? So see, it installed Maven this time. And then performed Maven packaging. Finally, archive the artifacts, which means it did the tar equivalent here. Then installed the Tomcat 7, which was not there. I removed it by purpose. And finally, deployment is basically to copy the file onto the web apps directory. So what it does is essentially creates one directory here. So if I do ls, okay, sorry for that, it's kind of breakout session. Okay, so we're almost there. Okay, so if I copy this IP address, because that's where I am running my master as well, colon 8080 slash cloud enabled, and then web app, right? So in this case, you can see that, this demo is showing up. Now, customers say this is like sprint one in DevOps. So that's what I was talking about, CI/CD pipeline, right? So continuous integration means there should be someone monitoring. Like now, customer says, Anil, I don't like this text box. And then there are 10 developers. Only one developer worked on this area, right? So what he can do, he has to go all the way and just commit the change. Before that, I have to tell Jenkins that whenever there's a change, what should happen, right? So that part we have not done. We have something called as build triggers. Here I'm saying poll SEM. If you see, poll SEM 5-star means I'm asking Jenkins to go and poll the GitHub every minute and just check what is the change in that, right? So the moment it does, it is going to apply the job. So let's go back. Here is my source code, and I just go here. I could have committed on Java Eclipse, but I'm just committing directly on the GitHub, and I'm just removing the code. This is my HTML which is getting streamed, and why you're getting that text form is because of this. Let me go ahead and edit, and I just say, just remove this form, and I just commit the change. So committing change means you are saving the changes you made to the source code. Just imagine you have like 10 million, like a million line of code, and you make a change, you commit it. You are not disturbing other developers. You just committed your change, and immediately you will notice job will trigger here in a moment. There'll be job number 1 which you got completed. You should see a job number 2 in any time now. So that should be like 60 seconds plus a few seconds, and you'll notice a job getting triggered. Sorry for the background noise, guys. There's a festival around in India, so can't help it. Okay, hopefully, yeah, that's there. So we have build number two, right? So this I did not trigger. Normally I do a build now. I did not do it. Automatically, it's just checked with him and did it. Of course, there is the install git. Okay, okay. So it's actually locked because I lost the connection, if you notice, last time to my machine here. So basically, the DPKG is locked. It can't install it right now. So let me just go back. I will do a machine. Since I'm not able to SSH, I need to do a stop and start. This will take a while. Between, I'll run a few other slides for you. Let it stop and start. Come back here. Okay, so let's power it on, and we should be up on our next. Okay, so basically, what we saw is this. Just to summarize again. So we have like source code. All of it was stored on GitHub. So I made a change, and Jenkins immediately triggered a job, and that job was going to compile package and make the changes which we had to. Okay. So let's the VM comes up, we'll run the job, and you'll see that form will be away. So that's the job of CI/CD. And coming to Docker, basically Docker is container technology. It's important if I don't cover containerization in a DevOps class. And I'm just going to talk very high level on Docker because Docker itself is a one-day program. I'm going to look at a case study. Let's say there's a ABC Software Limited in New York, and they are a software development company. And we'll see in 2003 when we had physical servers, how they used to run data center, and then we'll see how they transition to virtualization and then to containers. That's the idea. We'll just take the same customer and run him from 2003 physical, 2008 virtual, and 2018, which is today's container world. So basically, early 2003, we had everything in physical world, which is basically physical server running OS and an application on top of it. This is like Project A, IBM.com, for example, that ABC Limited is developing application for IBM. Then we had Project 2 for Infosys, then another one, Project 3 for Cisco. We buy another server. Just remember, this is a software company who is trying to work with different clients. So they used to buy physical server to isolate the application from each other. That's how things went. And if they get 100 projects, which is 100 different customers, they have to buy 100 physical machine. That's the only way which we had when I started my career as well. Like you buy a physical machine for one project and keep working on it. Now, obviously, there are disadvantages more than advantages. So one of them is you need to invest on 100 rack space in data center. So that's like you have 3 physical racks which you have to invest in. 100x the power cost, which is like you have to power on all the 100 machine. 100x the cooling cost, which is you need to cool down all the 100 physical servers, which you can't really help, right? So we like everything is like 100 times. So that's what we have. And we saw underutilization because every machine, remember these are developer machine, not running real IBM.com, right? Not serving the request. It's like I have 10 developers using one machine for using it for compile package once in or twice in a day. Rest of the hours they are just sitting idle. This is what we saw in physical world. Then early 2008, we saw virtualization. You're a technical or a non-technical. Everyone heard this name company VMware. The reason being, we'll learn that in this slide. Why they became so popular. He came back and said, okay, you want to run application, don't run server and OS on top of it. You buy the server, but run my hypervisor. Now, hypervisor is a technical term given to a operating system, right? Which is virtualization OS. And then using this hypervisor, you create something called as virtual machine. Now you create VM1 and say, okay, 1 CPU, 1 gig RAM. And then you install Red Hat Linux and then deploy application. Let's say, welcome to IBM, right? Project 2, you create another VM. So you keep creating, like, example, if you have 20 CPU server, you create like 20 VMs, and each VM will have 1 CPU. Got it? So now we could do only 20 projects, which means I am able to serve 20 clients on one physical server. That's the advantage. But what of other 80? Now we still have physical world limitation, right? So I can only run 20 VMs on this hardware because 20 CPUs. I can buy one more hardware and run 20 more VMs. So that makes it 40. So 40 customers we are able to serve, and then we keep scaling it out till we reach the goal of 100 VMs. Now within 100 VMs, so advantage here, you have only 5 rack space. Imagine your data center looks 95% reduction, right? So you're buying like 10,000 square feet, you only buy like 5% of it, right? 5x the power cost, which means you have to power on only 5 machines, and 5x the cooling cost. You have to only power, cool down 5 guys. 2008, the best job in the world was being a salesperson in a VMware company, because as a sales guy from VMware, you walk to a customer, CTO, and say, dear customer, I can save your cost by 95% for your data center, right? That's all the sales pitch, because that is very true. If you are developer guys, and then easily 95% of savings you could have done, because these are not running real production and you can still go ahead. So that's why VMware become very popular those days, and still popular. But today containers are changing the game. It's all going to be a little different from how virtualization used to work. But yeah, we still have problem with this architecture. What we saw was hypervisor is also operating system, right? So he will consume some CPU on the hardware here. Then you notice every VM is also running a OS, which means first hypervisor will eat some, let's say 20% CPU, then OS on every VM will also eat some CPU. And only then whatever leftover goes to your application. So we have two overheads. Like every physical machine will run 21 kernels. One kernel which is hypervisor, another 20 kernels which is the guest OS. So that's what we saw, that disadvantage, right? So each OS instance on the VM is going to consume CPU cycle and add the overhead on top of it. So that's where we transition to 2018, which is today's world as we speak, or as I do this class, right? So we are actually in the container world today. Now, what is this container world looks like? We have a physical server. We still cannot get away from physical. Let me check. There's a question. Do we have a question? No. Okay, guys, if you have a question, please put it on the chat box, and I'll take them. Thanks. Okay. So basically, what we are doing here is, in container world, we still need to buy physical server, but not as many as we need in virtualization. And then we install the operating system. Now back to school, right? So we say the best way to run your data center is you buy a hardware and install OS. Do not install hypervisor. We are changing the rules again. And once you install the operating system, you create containers. Like container 1, this will run like Ubuntu. Container 2, probably CentOS. Container 3 is probably SUSE Linux. Now you keep creating containers up to you reach your numbers. Now the advantage is you have one new rack space, because only one physical server you buy, and 100 containers means 100 projects which are isolated from each other. 1x the power cost and 1x the cooling cost. Now, who is the guy who is actually allowing you to do this container world is Docker. So Docker is allowing you to share the operating system kernel with every container. Very quickly, if you look at in virtualization, every VM had one operating system, right? But in container world, there's only one OS, and all this container one will share this OS, while container two will also share the same kernel. So in a very, very easy way to remember what is container and virtualization difference is, a container is exactly behaves like a virtual machine, but it doesn't have a guest operating system. It's like a virtual machine minus kernel is a container, as simple as that. Okay. So what they do, they use the kernel which is on your host machine, which is your physical server. That's how things work. And your container starts like in like 2 milliseconds, because the kernel is already running, right? When you actually power off and power on a VM, it takes like 1.5 minutes, because the kernel has to come up, right? The boot process has to complete. But in containers, it doesn't have to boot because OS is already booted up. You'll just use that kernel to boot up. So let me show you a quick demo on the Docker as well. So hopefully our machine is up. Okay. When I stop and start PM, the IP would again change. So I need to grab the IP address. Let me connect. Okay, so here we are. So basically, let's complete that part as well, which is our demo, which was pending. So I'm going to do IP address colon 8090, admin, and then root 1234. You notice what? The build number 3 is automatically triggered because it saw the server is available, right? I don't have to set up anything. That is continuous integration and continuous deployment. And if I go back where I got the text form last time, and this time on the very same server, it should not have the text form because I committed the code change. You see this? That's all gone. So that's the magic of pipeline. Just imagine you took like 10 months to develop travel.com for customer A. Now customer B comes in and say, okay, I want you to develop something called as itravel.com. You know what much time it takes to develop a new project? It's like Control F and replace travel with iTravel. That's all it takes. And you commit change within 1 hour, you have a new product which can go to your client, right? And you charge saying, okay, I need 8 months. Just trying to be more, aggressive on that. So the idea here is once your pipeline is ready, the source code will change, the features will change, but you are actually up and running. You're faster to market. Else we have is Docker part. So I already have Docker on this machine. Uh, so basically, if I do Docker info, it tells you that how many containers are running is 0, and this is a version of Docker which is 1.13, and also this is the amount of memory I have on Docker host, 7 GB RAM, around 7.8, and 2 CPUs. What I want you to focus is my Docker is running on Ubuntu 14. Okay, that's the OS, and it's going to be using kernel 3.13. So this is the kernel, which is a single kernel going to be shared with all the containers I'm going to spin. Okay, so if I do a Docker run -itd, and I'll call it as -name CentOS, and then the OS CentOS :7, then /bin and /bash. So on a Ubuntu server, I am going to run a CentOS container. The OS will be CentOS. If I do a Docker PS, you can notice a container called as CentOS is created. So just to do a uname-r, I am actually on the root of my Ubuntu server, right? You saw that. Now I'm going to log into this container, which is Docker exec -it, and this is the container ID which I need to log in. Docker execute login, Docker run is to create container, right? And then bin bash. So I want to get into a bash shell, and I'm going to do the same command, which is uname -r. Okay, I'm actually in the container. If you look at root at container ID, which is starting at 65A, and this is 65A here. This is a container, and this is CentOS, right? So if I do apt, it won't work. See here, apt command not found. If I say yum, it should work because it's a CentOS operating system environment. So it's exactly the same. So if I do uname -r, that's 3.13.0, and if I exit the container and do a uname -r on my host, it is the same. Now I'm going to create one more container, which is of Ubuntu. My host is Ubuntu 14. All right, so I'm going to create a container which is Ubuntu 16.04. Okay, so you see Docker PS, you see one more container, Ubuntu contains created. So command is same, it's Docker exec to login, but this time I'll use the container ID of Ubuntu machine. That's the latest here on the top, 542. And if I do a uname -r, he also shows up. I'm using 3.13, right? So it means CentOS container and Ubuntu 16 is sharing the same kernel as your host operating system. And if I go ls into this, you can see it's actually like any other Linux operating system, right? It has a bin directory, lib, media, mount, root, and usr, var, and everything. So that's the big advantage of running containers today. And they are lightweight. You can run typically like 100 containers on a machine which is 1 CPU, 1 gig RAM. Okay. So that's the advantage. And if you were to log in, you can do like apt update. Sorry for that, apt update here. And now within this container, you can run your own Apache server. So now you can install your application and start running it. That's the advantage of it. Okay. So I'm just going to clear it and exit the containers. So next steps, so configuration management tool. So this is the last leg for the DevOps session, and then we'll cover a little quick on cloud and then wrap up for questions. So basically, configuration management tools are nothing but these guys are a tool which can manage multiple OS. Like you notice Ubuntu, RHEL, Windows, SUSE. So what they can do, they can automate installing package. Example, let's say as an organization you have 50,000 servers, and on every server you want Apache 2 to be installed. It just takes 2 lines of code and hit enter. It will SSH to 10,000 machines or 50,000 in your case, install Apache 2 and come back, and it takes is 2 lines of code and 1 click, nothing more than that. That's automation. But once you install application, you might want to restart the service. Now 50,000 machine, you cannot SSH and do a restart of service, right? So you can write additional 2 piece of line code and say, okay, go ahead and restart the service after Apache is installed. You want to push some config file so that the application can start talking to database. You can push it. You can maintain like my app.conf file in CM tool. It can push that file to your etc folder on all the 50,000 servers in 1 click. Then you want to update OS after 10 days. You believe, okay, OS has to be updated. Believe me, it's like 2 line of code, and you hit enter. 50,000 machines, it will SSH, and all the 50,000 machines will have updated operating system. In addition to that, you can also look at sorry for this, Puppet Labs. Puppet Labs is another tool which is used for configuration. So basically it has Puppet server. This is where you put all your code, that code which I was talking about, and you have Puppet agent. Like you have 50,000 servers, on every server you install an agent, and this agent will take the commands from the Puppet server. Like Puppet server says install HTTPD. The job of agent is to install HTTPD. As simple as that, right? And then there's a console where you can log in. It will show you, okay, I have how many machines on the dashboard. There's a Puppet DB. It keeps a track, like how many machines are available, 50,000. How many applications have been installed, 50,000. Probably one application is uninstalled. It will automatically notify and keep a track on it. So Chef is another tool of configuration management tool. Basically, it has Chef server. This is where you store all the piece of code. You have Chef client. It's an agent which runs on every node. Then you have workstation. So normally they write all the code on a workstation. That is actually my Mac laptop, for example. I write a code on my Mac laptop. That's Chef workstation, we call it as. And then we push it to Chef server. And we tell on which node to apply it. That node will have the Chef client. Chef Analytics, so this guy will tell, okay, hey Anil, you told me to install HTTPD on 10,000 servers, but I could install it on only 9,900, but the 100 servers aren't installed. Reporting part, it can tell you. So what went wrong and all that you can get to know. Sorry. And Chef Supermarket. So let's say you don't know how to write a piece of code to automate Apache to install, right? So there's a supermarket where all the cookbooks are written. You just have to download it and apply them. Okay, shifting the gears to cloud computing. Just before that, just wanted to show you a small demo on Ansible as well. So Ansible is one more guy. So basically, Ansible works on architecture which is no agent. So this is most popular today in the industry, where you just have to write very less number of code, and it will just go ahead and automate all the tasks for you. This is one of the UI actually, which shows you the node part. So let me try to maximize it. Sorry. Yeah. Okay. Yeah. So you see 517 hosts here, which means there are 517 servers which are managed by Ansible. And tells you failed host means how many hosts it could not apply the changes you wanted. You can put some schedules, okay, run this job at this time and all of that, right? And it also tells you the activity which has been recently done on it. So it's a great tool to have. Ansible is one of them. It's commercially supported by Red Hat. But if you don't want this tower, which is the UI, then you can use it open source free of cost. That's not a problem. So cloud computing, we already know what is virtualization, but I'm just going to quickly cover the cloud part. So before virtualization, there is physical server. There's an operating system running on physical, and then you run application. But after virtualization, what you do, you buy a physical server, but install a hypervisor. So there are tools like VMware ESXi, Hyper-V from Microsoft, Zen from Citrix, and there are VMs running on top of it, right? So basically, each VM can run its own OS and its own application on top of it. So basically, the vendors, we have VMware, they have a product called as ESXi. Microsoft has a product called as Hyper-V. Citrix has a product called as Zen Server. So these are actually the three different hypervisors in the industry. So let's demystify cloud. First things first, I want you to know that virtualization does not equals to cloud computing, right? And that's actually a myth in the industry. So I will support you with one slide where I'll really demystify cloud and virtualization. So let's take an example that ABC Limited in New York, they want to build a private cloud and they don't want to go for Amazon and elsewhere, right? So what it takes to build a cloud today is three layers. First is physical infrastructure. That's where you have physical server, network switches, storage, and SAN fabric. And on top of it, you deploy virtual infrastructure. So what does virtual infra do? You are aware. Basically, you have hypervisors, which will allow you to create virtual server, virtual network switch, virtual storage, and virtual SAN fabric. And third layer is where cloud software is which you have to invest. It's provides you a self-service portal, a service catalog where you can just log in and you see that okay, we have Windows Server and Linux Server offering from our customer. So you can choose either Windows or Linux. So basically, when I deploy cloud software at ABC, all the employees who log into the office can type cloud.abclimited.com, right? So they get a website. And in that website, when they log in, they'll see there are Windows templates and Linux templates. And if I'm a Windows developer, I'll just go ahead and use Windows, right? So as simple as that. And then automation kicks in. The cloud software is integrated with your VMware. So what does cloud software do? It will send an API request saying, hey VMware, can you create a VM for me? That comes to your virtual infra. And VMware will create the VM on the physical server. Once created, VMware notifies the cloud software again, yes, I have completed VM creation. And the job of cloud software is on the very same portal, that's where user requests the VM, right? It has to publish username, password, and IP address. Sorry. And then using this, you can deliver infrastructure service, platform as a service, and software as a service. So basically, these are three services today in the cloud. And you can use VMware, Hyper-V, Citrix, or KVM at the hypervisor layer. And at the cloud software layer, very popular is OpenStack. You can install OpenStack. It's open source and integrate with VMware. Second option, you have VMware vCloud Director. It's a paid product. Now it's called as vRealize. And we have System Center from Microsoft, another cloud software, commercial. And we have CloudStack, open source cloud software. So we have several options for cloud software to choose, but today OpenStack ranks #1 in private cloud software because it is open source. So now what do you mean by infrastructure service? So basically infra service mean you get a virtual machine which is running Windows or Linux, and you also get dedicated servers today. Like if you go to software IBM, you say, Anil, I don't want a VM. I have a project where I need an entire physical machine. So you can actually go ahead and provision a physical server with 8 core 16 gig, and they will give you as a service. You don't buy it, you rent it for those many hours. In addition to that, in platform as a service, you get a platform where you can deploy your apps, right? So if I'm a developer, I wrote a Java app, I just need a machine where I can deploy my application. So that's where platform as a service comes into play. So normally cloud provider will say, okay, you don't worry, just give me your app. I will deploy all the virtual machine, load balancer, database for you. I'll take care of it. Right? So that's the PaaS. SaaS is basically the end product, which you use Salesforce, CRM software. Office 365 is email software, where Microsoft is deployed Exchange server in their data center, and they say, okay, you are a 10 employee company. I take care of Exchange server, DR, disaster recovery, and backup. You don't worry. Just spin up mailboxes on me and start using it. So that's the software as a service. And Google Drive, you are aware, where you can create docs online, right? So basically, without installing any software on your laptops. So thank you so much. I know I was a bit rushy for the last few minutes because I wanted to end up with one small demo on the cloud, and also wanted to see if there are any questions I can take up. So there's some noise, background noise coming in. So I'm going to mute for a few seconds and then I will resume back. Okay, so I'm back. Basically, this is the cloud portal of Amazon Cloud Provider. It's a public cloud where, as I told you, service catalog means they offer various service. EC2 is nothing but virtual machine as a service, which is also called as infrastructure as a service for us, right? And they have other services called as basically Lambda, which is serverless. We have other service called as S3 for storage, RDS for database, and many others. So Amazon is #1 today. undoubtedly, because they were early more advantage as well. Plus, the technology is great, of course. So I'm going to do a demo of infrastructure service quickly. EC2 is Elastic Compute, where you get virtual machine. I'm running like 2 instances already. VM is called as instance in Amazon naming convention. Click on launch instance, and then here is a service catalog. So you can choose like Red Hat Linux, Ubuntu Linux, SUSE Linux, Windows Server 2016. Your choice. I'm just going to select Ubuntu here, and then maybe you are deploying your application, which is Oracle. Then of course you can't go with one CPU, 1 gig, right? So they give you option of running more than one CPU and 1 gig. So you have one CPU 2 gig plan, two CPU 4, and all the way you can go up to a largest VM, which is 128 CPUs and 3.9 terabyte of RAM. I'm not talking hard drive, I'm talking RAM here. Okay, it's a pretty largest VM. You won't see any virtual machine issues today with cloud provider, because you have enough CPU and memory which can help you to run your application. You won't have a application it really says, okay, I can't run on server which is like 1 terabyte RAM. You can say, okay, I get it 4 terabyte RAM. So that's big today. Of course, higher the configuration, your price goes up. I'm gonna stick to T2 micro for now, just for demo. And you can say in one go, I need like 20 instance. I can. Let's say I want like 5 VMs. I'll ask for 5, and to spin up 5 instance for me. So add storage. This is a root disk C drive for your VM. You can say I want 40 gig. He'll provision 40. And here tags, I'm just going to call it as demo VMs. Secondary group is like a firewall. Since it's not a training, just a demo, I want to keep you posted that I'm opening up SSH port because I have to SSH to this VM. And then we launch it. They have a concept of key pair. When I want to log into this VM, I need to use this key pair. So I'm just going to call it as demo -ml. They don't allow password authentication here. Then we launch the instances. If I go view instance, you should notice the VM should be running. Yeah, so you see demo-VM, they are coming up here. Sorry for the typo there. Demo-VM. I'm gonna just mute for some time to avoid the background noise issue. So once its VM is initialized, you can notice we're getting an IP address here. So we just click on connect tab. We need to do a chmod 400. So here's our terminal. I'm going to exit from my machine. A new window and CD2 downloads. So demo on chmod, and then followed by that, I'm just gonna copy this SSH string, and I should be into the VM very soon. And then I should be in. Yeah, that's it. So we are actually in the Ubuntu server now. So thanks so much, guys. I hope it was useful session, and I'm really sorry for the background noise. It was not expected. It's a festival this side, and it's a street ride, which is like they just appear. You can't control those, not planned. And I'm just going to be on mute for now and wait for any questions here on the question box. If not, thank you so much for watching this session and have a great life ahead and a great career, of course. Take care. Right, so I see some questions. I'll go with the very last and then come up. Uh, so Microsoft difference between poll SEM and GitHub. Okay. See, poll SEM is basically you're telling GitHub, you're telling Jenkins to keep polling SEM tools. Like you're telling Jenkins keep talking to GitHub and see whether they change. But that's a too much overhead. So what you need to do is there's a GitHub plugin which is available where you can do a webhook plugin. How about this, right? So Jenkins is talking to GitHub saying every minute, do you have a change? You know, you kind of get irritated. You are a person, right? It's so much of work. How about GitHub informing when there is a change? It's like 10 minutes, 10 times Jenkins is going and asking you, do you have a change? Instead of that, GitHub says, okay. After 10 hours, he says, okay, I have a change. That's the best part, right? We can configure. And Vinita, your question looks little incomplete. It just says microservice here. Can you tell me something about Kubernetes? That's the Mehul's question. Okay. And Kubernetes is basically orchestration tool. You saw that I could spin some container in Docker. So what Kubernetes does is you can say I'm running IBM.com and you tell Kubernetes, I want you to run this on 100 containers. So what this guy will do, Kubernetes will spin 100 containers and it will be running on, let's say, 10 physical machines. If physical machine one goes down, what happens that you ask for 100 containers, but reported is 10 containers. So the job of Kubernetes is to create 10 more containers. It will always maintain a desired state number of containers. So that's the job of Kubernetes. So you said 100 containers is what I need. It will maintain 100 always. You know, that's the job of Kubernetes in today's world. Shubham says, since I joined very late, so missed almost full session. So sorry to hear that. I'm not sure about any communication gap, but it was published for 7 to 9 p.m. India time. Ikta Verma says, okay. Yeah, Omid actually asked for Kubernetes. I did answer that. Prasad, he says, very informative, clean and awesome webinar. Thank you. I'm so thankful to you guys for listening. It's very hard when you do a webinar, honestly, these kind of concept. Attempt is to just give you a very high level overview. Of course, nobody can expertise in a webinar, but as long as you felt it worth investing time, I'm glad that I'm able to honor your time for taking out for this. I really appreciate your time. Thanks, Prasad, for the feedback. Difference between Jenkins and Kubernetes. So that's the question from Debanjana, sorry. So basically, Jenkins is an orchestration tool, while Kubernetes is orchestration tool for containers, right? So Jenkins, you can say whenever there is a change in GitHub, you know, do this and do like download the clone, git clone software, and all of that. But Kubernetes is container infrastructure management tool. Oh, there are two different things. So Kubernetes will orchestrate container deployment. Like you say 100 containers is what I need, he will deploy 100 for you. Okay. While Jenkins, you say, okay, do this all the tasks. You know, you put some periodic like a program, which is already a demo. I think you got clarity there. This could be a old question for us. Karthik says, thank you for the session. Thank you so much. Shubham, can we have recorded videos that I think you should not be able to get? I can check with the team and come back. And we have thank you note from Yadav. Thank you. The session will continue for tomorrow or end of today. This is just a 2-hour session as a precursor to everything. We have a host of trainings available around DevOps where you'll get more of hands-on. Kubernetes is not covered, so that's the Nilesh. Basically, Nilesh, so the agenda was to focus on DevOps. Kubernetes is just one of the tool within DevOps. So I do run multiple webinars where I do only Docker Kubernetes for 1 hour. Hopefully, we have you in our database. We will keep you posted when it appears. But that's an exclusive session on microservice, APIs, and Docker Kubernetes. So that's a different track altogether. Since this was our first effort to get everyone onboarded on DevOps, I know the name might be confusing because the title was Docker Container Kubernetes. Maybe misarticulating, but yeah. So Kubernetes is actually going to be a different focus webinar altogether. Okay, Prasanna, can we expect Kubernetes? Yeah, I told you. Okay. All right. So let me do one thing. I'll just do one slider for Kubernetes. So that's better because I think most of you guys are actually wanting for Kubernetes. Just give me a moment. I'll unshare and share my screen in a minute. All right. Thank you. Hope you guys can see the screen. I just pulled out one of my other slide, but this is the slide which I run for all the sessions. It's an animated slide. It takes like around 6 minutes, but gives you clarity on the Kubernetes architecture. Basically, Kubernetes has a concept of two node cluster. So we have something called as Kubernetes master. It could be a VM or a physical machine running Linux. And on this machine, you run some component called as Kube API. Now, Kube API is like a front end. So when I said, like you said, I want cognitia.com on 100 containers, you submit that request to Kube API. Kube API is the guy who is like a request taker. You just say I want 100 containers. The request comes to Kube API. And there's a Kube scheduler which runs on master. His job is saying, okay, how many Docker servers I have. His job is to check, okay, I have 3 Docker hosts and I can spin like 30 containers on each. So his job is to schedule the container. Like he will decide, okay, host 1, please run 10 containers for me. Host 2, you run 20 containers for me, right? So like a scheduler, decision maker. And there's controller manager. This guy I will talk in a minute, just after a few animations now. And HCD is like a database, that's where you store all the information like, okay, how many Docker hosts are there? 3. How many containers are running on each host? Maybe 1, 2, and 5. All the information like what is your cluster size, how many CPUs are available, how much are consumed, all the information. Like example, like customers ask for 100 containers, even that information is stored on HCD. HCD is think of like a database in Kubernetes for you. Then we have something called as minion nodes. So minion are nothing but, by English term, these are like slave nodes. They are just the followers. They follow the instruction which comes from master, as simple as that. Just visualize master as your project manager at your company, right? And minions are like the employees who reports to that project manager to do some work. So unless the project manager says work on this, they're not going to work on it, right? So minion node runs Linux, and they of course run Docker. This is where all the containers will run. The containers which I spoke about, they run on the minion nodes, not on the master. And there's a kubelet agent because Kubernetes has to talk to Docker. They cannot directly talk. They develop an agent. And Flannel is one of the network provider, which allows you to create networks across hosts. In this architecture, we have 3 minion nodes and 1 master node. I'm going to take a very small example. Let's say I want to run ibm.com and I want 3 containers. So I supply that request, and then scheduler will send one request to minion 1 saying create a container, minion 2 another, and minion 3 another. So scheduler decides where to run, correct? So basically, now Kubernetes master is a container orchestration tool. So it will spin one container on each host. Now for whatever reason, let me see if I can get sorry for that. I need to get one marker here. Yeah, I got it. What if this node fails, right? So basically we have C1 running here earlier, container 2 was running here. and container 3 was running here. So what is the desired state? 3 containers should be running, right? But reported will be 2 right now. So the controller manager job, which is this guy, is to go to HCD and see, okay, how much is required? 3, but report is 2. So controller manager will tell the API that, okay, required was 3, but I only see 2 here. Then API will send request to scheduler. Now it's a job of scheduler to spin one more container. Probably he might place C3 here, right? So he'll always maintain reported state. Then it will be 3/3. This is the fastest I can do Kubernetes. Of course, Kubernetes is the most ocean-wide knowledge required. But just I think you got some overview about Kubernetes, so what Kubernetes is all about, right? Thank you. So we already extended 5 more minutes. Is this similar to Shivam? Voice is breaking. I think it was momentary. Hopefully, okay. I think somebody thanked for this Kubernetes slide. Thank you guys so much. I know we extended more than a few more minutes beyond the specified time. I'll be signing off and see you sometimes on next session.